we're going to be looking at the volume of rectangular prisms. And the first thing to think about is volume. What is volume? And we're going to be doing volume of many shapes. So we need to have some kind of handle on what volume is. So I have a simple definition here. I put volume refers to the amount of space that's inside a figure, right? And I put over here in red, it's a container, okay? We're talking about containers. And in geometry, typically we're looking at very specific shapes, rectangular prisms, triangular prisms, cylinders, pyramids, cones, all those things that can be filled in with something, okay? But they tend to have very specific shapes in geometry. Not always, but they tend to. And that's what we'll be looking at. So anyway, for rectangular prisms, when I'm starting to think about a rectangular prism, I think about boxes, and that's what I said over here. It's just basically a box, you know, and we'll be looking at the cube, which is, in my opinion, a very specific kind of rectangular prism. Some people might disagree with me and say it's a cube, it's not a rectangular prism because it's not rectangular. But for me, they're both boxes, okay? They're all boxes in this case. And because they're all the same box shape, box-like shape, they're going to have the same formula to solve, and that formula is going to be length times height times width. Now some people like to say base times height times width, or base times height times side. I've heard that. And it doesn't matter what you want to name it, what you want to call it, but it's how you visualize the shape that you're working with. So since we're dealing with boxes, I asked my students, how would you describe the shape of a shoebox? How would you describe the shape of a shoebox? With your hands. With your hands. Jazz hands, right? So some students go like this. It's about like this and like that. They do that with their hands. But what are they giving me when they only do this? They're giving me one dimension, two dimensions, but what happened to the third dimension? So imagine if you're going to be doing that with your hands, imagine you have to put your hands on all opposite sides of the box. So this left side, what is it for you? Is this your left or my right? Anyway, this right side and this left side are opposite. So put your hands there, that's one dimension. The top side and the bottom side, those are opposite sides, but that makes one dimension, one length. That's another length, okay? But the third dimension is the front and, the front and the back, right? And so one dimension, two dimensions, and that other one that has a depth, a third dimension, okay? If you multiply all those three dimensions, and it doesn't matter in which order you do it. I have it here, length first, height second. No, it doesn't really matter. You can go backwards. You can go width times height times length, or mix it up, width times, or height times length times height, whatever. It doesn't matter because you're multiplying. When you multiply, you're just basically grouping it all together, and it'll group together the same way no matter which one you start with, okay? But again, it's that important thing about visualizing those three dimensions. You gotta think about those three dimensions. Put your hands on all 6 sides, and that will be the 3 dimensions. Okay? All right. So, okay, now most of these geometry problems can have algebra aspects to it. And what does that look like? Well, when it's more of an algebra kind of problem, you still need to understand the geometry concepts. But typically, like for example, we'll be doing some examples of these, but real quick, length times height times width will give you the volume of a box or rectangular prism. It'll give you the volume, but sometimes they'll give you the volume of the box, and then they'll ask, well, what's the height? And they'll give you the length and the width, but they want to know how tall that box is. And it's kind of where you got to work the problem backwards, where you start off with the volume and you have to go back to a part of the formula, whether it be the height or whether it be the height, the length, the width. They'll ask you for one of those aspects of the box, one of those dimensions. And working backwards like that typically is better if we use algebra. Some people can get it right, or get the answer right, by kind of guessing and kind of trial and error and kind of things like that, especially with multiple choice. Sometimes when a multiple choice problem, they'll just plug in the value for all the answers that they have in multiple choice, and just plug in the value in that empty value in the formula. So like if it's length times something times width, they'll just keep putting each one of those options into that something until it equals what the volume was originally, what they give you, right? They tell you what the volume is. That works. Okay, I'm not going to say it doesn't work, but it does if your algebra is strong. If you're strong with the force, if your algebra is strong, you can actually get to the answer faster. If your algebra is weak, then maybe trial and error might be the best way for you, but sometimes the problems aren't all multiple choice. So then what do you do, right? So we're gonna go ahead and get started and take a look at some different kinds of problems, okay? Okay, so our first problem is gonna be the classic cube. Okay, I still like to call it rectangular prism, but whatever. It's not a rectangle, it is a cube. But it is a box. We can definitely agree on that it is a box-like shape. And I'm missing part of my line here. Okay, so the basic question with this kind of problem is what? What is the volume of the cube? What is the volume of this box? And I have the formula written here, and I think I wrote it differently this time than at the beginning of this video. So I think I had height in the middle, length times height times width. But like I told you earlier, it doesn't really matter which order you have it in. The idea is that you're going to multiply all three dimensions, and it doesn't matter, you're just grouping them all together. So, you know, multiplying doesn't change the end result. Division, changes everything. But multiplication, we're good. Doesn't matter in which order. Okay. So again, like I was telling you earlier, we have to think about those three dimensions of the box. This measurement, and I think that measurement would be right here, right? The 3 here. So that one times this one, and this measurement, I have it right here. If it was written over here, then I would take it from here. If it was written over here, then I would take it from there. I just need one of those vertical lines, right? This one, this one, this one. One of those needs to tell me how high it is. And that's all I need. I don't need to use all three of them, right? I don't need to duplicate this, right? I just need one of those, one representative of that dimension, okay? So again, we have this one, we have the length, we have the height, and we have the depth or the width. Now, I mean, this is a pretty easy example. It's gonna be 3 times 3 times 3, which is equal to 27, okay? Another way to, how else do we say, well, let me just put the volume here. So volume is 27 centimeters cubed. Okay? And we put centimeters cubed, or units cubed. Remember, the unit is whatever this is, centimeter, inches, mile, whatever, okay? So we put units cubed on these kinds of problems because that means that we're talking about volume, okay? We're talking about the space within something. How much space is inside of a shape? In this case, the cube. Now. Okay, yeah, that's what I was gonna say. What's another way, since I can use this example, what's another way of saying 3 times 3 times 3? Or better yet, a number multiplied by itself again, multiplied again by itself. Remember about exponents, that's basically 3 cubed. Okay? Basically 3 cubed. So let me go back a little bit here. Let's play a little bit with this because I'm going to take this away, take this stuff away, this stuff away. Okay. All right. So, and I took part of my box away. Oh no. Okay, so now we're going to look at this problem a little bit differently. We're going to look at this like one of those examples where they make us or want us to use algebra. And when it's a cube, it's easy peasy, easy, okay? Don't overthink it. However, I do understand that these problems can be difficult to understand or to visualize, and then it's sometimes hard to think about where to start and what's the first step kind of thing. And I've even seen it harder when they don't give you the picture. They use words to describe it. And I saw one with like a table. It was like you can imagine this or something, but they don't put the picture. And they said it was a glass table, and I think it had like a hollow, and the glass table was in the shape of a cube, but it wasn't a solid piece of glass. It had a middle that was empty. It had a middle void, like a middle empty space in the middle, a hollow space. That was a cube. And they tell you the volume of that empty space in the middle. We can imagine that volume of that space, of that table, is 27, well, it would have to be inches or something bigger, but we'll just say, for the sake of argument, 27 centimeters cubed. And then they ask, what is the measurement of one of its sides? And then my students, a lot of my students, not all of them, but some of them do get like, what? Well, what? I don't even know what they're talking about, right? And we have to pull that information out of the text. When they say cube, that's super important. What is a cube? Cube means that it's a three-dimensional box, three-dimensional figure that has well, it's a cube box, but not just any box. Every one of its sides measures the same. So because of that, whatever this measurement is, it's going to be the same measurement here, the same measurement there. Anywhere you measure, it's going to measure the same because it's a cube. That's actually very key for that kind of problem. And they do it with squares. I've seen it in area. They'll give you a perfect square. Don't overthink it. It's easy. But it is hard to visualize, and I do understand that. I do understand that. All right, so how would I approach this kind of problem? Well, again, like I was saying, all the sides measure the same. So I know whatever the length is, the width is the same thing, and the height's going to be the same thing because it's a cube. So I need to take this information from the problem. They're going to give me the volume, and they typically do anyway. They give you the volume. They say the volume is this. So okay, we have the volume. I'll just kind of move it around here. I'll put it down here. The volume is 27. So volume, imagine volume is equal to this formula, and that's going to equal 27. But I don't know what these measure. I don't know what these any one of these measurements are. All I know is that they're the same, and I know that they're the same because it's a cube. So I could say whatever this number is times this number and times that number. I need something to represent those numbers, the same number. What I would do is I would say, well, the length is going to be one number. Here, let me. You know what? Let me use another color too. Let me just change that up a little bit. So I'll say the first number, the first length is x. But because it's a cube, they all measure x. They all measure the same thing. So this one, the width in this case would be x, and this one would be x. I'm going to go ahead and use a dot just to not confuse the little x's and big x's, okay? The dot would mean multiplication. So it would be x times x times x. Or the number multiplied by itself again is going to give me 27, right? What's another way of saying x times x times x? X cubed. All right, x cubed is equal to 27. Now, this is where your algebra comes in. This is an equation. A number x cubed is equal to something else. We have an equal sign and information on both sides of that equal sign. It's an equation that can be solved. So, okay, so let's go ahead and see if we can figure this out on the calculator. Okay, well, trying to get ready here. Okay, so how would we approach this kind of problem? What would be the step? Let me go and move this over a little bit. What would be the key step to solve this problem? X is almost isolated on one side of the equal sign, so what do we have to do? Well, how do we undo a number that's cubed? Well, we take the root cubed, right? Or the cube root, I mean, the root cubed. We take the cube root of both sides. What you do to one side, you do to the other side. So over here, it's real simple. We had a number that was cubed. We took the cube root of it. All that just cancels out, and it just leaves us with x isolated by itself. Now this, hopefully, you guys are good enough with your multiplication tables. You guys can see what this answer is. This is basically saying what number multiplied by itself 3 times equals 27. We already know the answer, but I'm going to go ahead and show you. And I said we already know the answer because I did it before. But I'm going to go ahead and show you on the calculator here. Okay, so on this calculator, I have to, my cube root is right here. Well, it's not really a cube root. It's just an x is an option value. I can write it a little bit bigger over here. On the calculator, it says something like this. It's this thing like this. Okay, which means that the value of the root can be a variable. I can change that however I want. I can put whatever number I want here. In this case, I'm going to want a cube. Okay, so in this calculator, I have to put the cube first, and it looks just like a 3, because that's what it is. So I hit the 3. Okay, can we see that? Yes. And then I have to obtain that little function, I have to hit the second, because it's in green. And then I'll hit the button that is this little caret. They call that a caret, that little looks like an arrow pointing up kind of thing. But it'll actually access this function up here. Okay, and then I put 27. Okay, and equals, can't see my equal sign, equals 3. Okay, so in this case, in this calculator, you have to put that value of this number here first. If it was a fourth root, I put 4 and then root and all that. Okay, so anyway, if you have a calculator, and you probably will if you're doing a test or something like that, it's the hard part is really visualizing that it's a cube. And what does that mean? Well, it just means that all the sides measure the same, and you can represent that with an x or any letter. S, if you want to say side. Side cubed or x cubed is equal to 27. Cube root both sides, x gets to be by itself, and you do this cube root, and you'll get 3. And that's basically trying to tell you, or is telling us, that each side measures 3 centimeters, okay? I'm not going to write it on all of them, but okay, you get the idea? So that's kind of an example. This is an easier example, I would say, of how to get to the answer relatively fast using algebra. I mean, the explanation was kind of long, but that's how you would do it, okay? So pay attention to those. They'll give you the volume. If it's a cube, you got to understand what a cube is. It has very specific characteristics, and it just means side times side times side is all the same. We can abbreviate that with an x cubed instead of making it all big like that. Cube root both sides, you get the answer. Okay, good luck. Okay, so now we have what would be considered a true rectangular prism. And as we saw in the last problem, we worked with with a cube. It's a special kind of rectangular prism, in my opinion, where all the sides are equal to each other. But it's interesting when we have to apply the algebra to it, right? Because it turns into this thing that needs a square root, or I mean a cube root, to solve. And so keep practicing your cube roots, okay? This is a little bit different. You're not going to use a cube root because the sides are actually different. So when they're different, there's a different application of algebra skills that we apply to this kind of problem. And that's what we're going to do now. But first, before we apply the algebra, we're going to solve the volume. Oh, sorry, I ran right into the board. We're going to solve the volume of the rectangular prism using our formula: length times height, length times height times width, or length times width times height. Again, just to emphasize again, re-emphasize, it doesn't matter in which order you multiply these. The idea is that you multiply all 3 dimensions, right? Okay. So the length, I guess I'll say it's going to be 8. Some might say it's 10. Again, it doesn't matter in which, the idea is to get those 3 dimensions, and that's it. So I'm just going to put 8 as the length. The height in this case is 5, right here. And the width, we'll say that the width will be the 10, right? So we just got to multiply these 3 dimensions, and that'll give us the volume of this rectangular prism. And again, it's the box, right? The cube is a box. It's a special kind of box, but that's another kind of box. So they're all the same. It's just multiplying those 3 dimensions. So 8 times 5 is 40. 40 times 10 is 40 with an extra 0, or 400. In this case, it's inches cubed. Okay, so that's the volume of that rectangular prism. So it's not too bad, right? It's pretty easy. It's not too crazy. Now, let's turn it around, right? Let's turn it around. Let's use algebra and use a typical kind of problem that they might give you. Where's a good place to put the volume? I'll put it right here in the front. So the volume is 400 inches cubed. Now, let's take away the height. Okay? So now this kind of question, what they'll ask you, and they might take away the height, they might take away the length, they might take away the width. It doesn't matter, but they'll probably take away one of those values. And they'll give you the whole volume of the rectangular prism, of the box, right? They'll give you the volume of the box. But one of these 3 will be missing. And it'll be your job to figure out, well, what's missing, or how do I find the value of what's missing? Again, trial and error might work, but it's not the best way to approach this. What I mean is, you might go, 8 times 10 is 80. 80 times something has to give me 400. And that's basically that's basically what algebra is. But algebra has a method to solve that, a process that will bring it to that, to bring you to that answer, instead of just kind of trial and error, guessing and guessing and guessing until you finally get to the right answer. But let's go ahead and take a look at this. So what's a good way of doing this? I'll go ahead and use parentheses, I suppose. So I'll use 3 pairs of parentheses, all connected to show that they're multiplied. And in each one, I'll put the value of the length, the width, and the height. Okay. In this case, I think I'm going to leave the height at the end. I'll just put an h. Okay. In fact, I'll put a lowercase h, just because I think it looks a little bit better when we're dealing with algebra. And the length we have, I said earlier that the length, we'll call it the 8 in this case. The height we don't have, but I told you I wouldn't put the height at the end. Again, it doesn't matter in which order we put these. I'm just trying to express it in a certain way that kind of looks better, I guess. So the width we're going to say is 10. So I have the same formula. Again, I flip-flop these two, but it's the same thing. Don't worry about that. They're all going to get grouped together anyway. So again, like when we were doing the cube, the thing we have to ask ourselves is, how did they get 400? What did they do to get 400 as the volume? So if they give you the volume, then you have to understand. You have to start out at the formula of the volume. How do you find the volume of any rectangular prism or any box, right? The cube or this kind of box. So they multiplied these 3 things, and they gave them 400, right? So we have it here with the information that they also gave us. They gave us the length and the width, and they're asking us for the height. So they multiplied this times this times this unknown, and it equals 400. Now we have a basic equation. We have an equation that is ready to be solved. Okay? So again, we want to, when we're solving equations, we want the variable, the letter, to be alone and on one side of the equal sign. So it's already on the left side of the equal sign, right? And I might as well just leave it here, and then the idea would be to move the 8 and the 10 over to that side. But before we do that, we can simplify this left side. There's an operation that we can do before moving it over, and that operation would be the multiplication, 8 times 10. So let's go ahead and do that. So 8 times 10 is 80. I'm going to go ahead and get rid of the parentheses. I can just say 80h, okay? 80x, 80 whatever letter I want to use. But since we're talking about height, might as well put the h. Equals 400. Okay? Now this is 80 times h equals 400. So again, I want to leave h alone on one side of the equal sign. I don't like my h too much. On one side of the equal sign. So to do that, I have to look at the relationship between the 80 and the h. What operation, mathematical operation, is keeping or has the 80 and the h together? What's the relationship? Well, when two numbers, and you got to understand that h is a number, it's just an unknown number, so when it's an unknown number we use a letter, but it is a number. When we have two numbers that are connected together right next to each other, it means that they're multiplied. So to undo that multiplication and get the 80 separate from the h to be able to move it over here, I have to do the opposite of the multiplication, the opposite operation, and that would be division. Okay, I'm going to divide by the number I want to get rid of. Divide by the 80, so I can just get rid of the 80 and leave the h alone, right? We want h isolated all by itself. So whatever number divided by itself is 1. 80 divided by 80 is 1. 1 h is just going to be h, because 1 times h is h. 1 times 10 is 10. 1 times pizza is pizza. 1 times h is h. Okay, and again, my h's are not coming out good today. Anyway, all right, so, but what we do to one side, we have to do the exact same thing to the other side. So what we did over here was divide by 80. That's what I got to do over here, divide by 80. Okay? And then, well, I mean, zeros, if you have a numerator and a denominator, and they're the the last numbers that they have are zeros, you can just cross them out. That's like we're reducing it by 10. We're dividing both of them by 10, making it a smaller fraction. And now we have something that's pretty simple, 40 divided by 8, and that's just 5. Well, we knew that because we started off with 5. We kind of knew it was going to be 5 inches tall. But it's kind of nice to see how the algebra works at undoing parts of that. Well, it's basically you're reverse engineering the 400 as a volume. How did they get volume? Well, they multiplied these three things, and if one of those is missing, you can find that just by using algebra, isolating the variable on one side of the equal sign, and practicing your algebra skills, of course. All right, so like I said, we did it a very typical way where they asked, what's the volume of this? And we just went straight forward, multiplying length times height times width. But sometimes they'll ask us, they'll say, here's the volume of this box or rectangular prism, and they'll give you two of those three dimensions, and then they'll ask you for one of them. And again, they could have given us the 8 and the 5, and we could have solved to find the 10, or they could have given us the 5 and the 10, and we could have solved for the 8. It's the same thing. Okay, so yeah, now let's look at one more very typical kind of problem that they ask us. Okay, so let's take a look at that. All right, now here's a problem that I see a lot, and sometimes they use two figures that are similar. Sometimes they use one that's like this and another one that's like a cylinder, or another one that's like a cone, and you got to figure that stuff out, right? But it's the same kind of problem, but we haven't, at least not yet, we haven't talked about the cone or the pyramid or the cylinder. We'll get to that in just a second. But I guess what I'm trying to say is this kind of question is common, all right? So let's take a look at it. And by the way, I'd like for you to maybe even stop the video and see if you can solve it before I do it, okay? So the question says these two figures have equal volumes. So let's take a look at the figures. We have a cube that has a height of 6 centimeters, and then we have a rectangular prism that has two dimensions. It has like I don't know what you'd call that, the length and maybe the width, a length of 8 and a width of 8 centimeters or 9 centimeters. And it looks like we're missing the height, and it says what is the height, and obviously I put it in red to kind of show the connection there. What is the height of the rectangular prism? So your question is, how much does this measure? And like I said, this kind of question is very typical. So why don't you go ahead and stop the video and see if you can do it. Okay. So what did you get? What'd you get? What'd you get? All right, well, let's see here. How do we get to this height? Well, I talked about in the last video that if we have the volume, we can work backwards using algebra, right? So they say, and we can use that because it says very important information that the two of them have the exact same volume. In other words, that means that they can contain the same amount of material. If you fill them up with water, they'll take the same amount of water, both of them. They're the same volume. So, okay, so if they have the same volume, can I find the volume of one of these two figures? And the answer is yes. The clue is in this figure. We can find the volume of the cube. And you might be asking yourself, well, they didn't give me the length and the width. They gave me the height. But that's why we have to understand those little characteristics of what a cube is. A cube means that every side, no matter how you measure it, is going to measure the same. So if we have one of those sides, we have all the sides because they all measure 6. And that's what a cube is, right? So I guess I could just go in here and write a 6 down here and maybe a 6 over here, right? And they're centimeters. I'm just not going to put the cm. But okay, so how would we solve that, right? Well, we have to multiply the three dimensions, 6 times 6 times 6, or we can say 6 cubed, and that would be the volume of the cube. 6 cubed would be the volume of the cube. Where should I put that? Should I put that over here or over there? Let me put it over here, and actually I'll put it in red too. Okay, let's try that. So 6 cubed, and that will be the volume of the cube. And I'm going to go ahead and show you on the calculator like how to do that. There's a couple different ways, I think. Well, at least one. No, there's at least two, I mean. Okay, so get the calculator out, right? See if we can get it more or less in focus. Now, one way you could do it, because you know that multiply it to find a cube of something, you just got to multiply itself, that number, the base, in this case the 6, by itself 3 times. So 6 times 6 times 6. Yes, you can do that. You can go 6, 6, well, let me make sure you can see that. 6 times 6 times 6. I didn't push the button, but oops. But I want to show you another way, okay? See this little caret? They call it a caret. It's like a little arrow thingy that points up. but it's not really an arrow, okay? It's I guess you can say it like to the power of, right? You can say that. That's what that button means. It means to the power of. All right, so let's try this little trick here. I'm gonna try to get it, the calculator more or less in focus. So 6, that button, that little caret button, to the power of, you can see what it looks like up here, maybe, geez, to the power of 3. So 6 caret 3, and that equals 216. Okay, and that's all you do, and that will work for any of them. 2 to the or 6 to the power of 5, 6 to the power of 12, and that's why when they get huge, not that you'll ever really have to do that, at least not for like the high set or the GED test, but it makes it a lot easier than going 6 times 6 times 6 times 6 times 6, you know, 12 times, right? So you can just go 6 to the power of, and then bam, you're there. Okay, so that's what that little caret button means. All right, so now we know what the volume of the cube is. It's 216 centimeters cubed. All right, so that means that this thing is 216 centimeters cubed. Because remember, they said that they have equal volume, so the two of them measure the same, right? So that's a big clue. We had to figure that out. But we did, like I said, we had to understand what a cube is. They give us one side, they give us all the sides, right? And then we have to find the volume, which means we have to multiply this times this of the cube, and then we got 6 cubed, which is 216. And now we're ready to solve this equation. This is going to be an equation just exactly like the last one we did. All right, so let's go ahead and put the formula up. I'll leave height till the end so that we can say maybe length times width times height, right? And I'll put it in capital letter here, but I'll probably put it in a lowercase when we're doing the equation. Okay, now, so length is 8. And in this form, I'll put parentheses. Width is 9, and then we're missing h. And here I'll start putting it in lowercase. Now, why am I doing this? Because what I had to ask myself, and I didn't ask myself sooner or earlier, was how did they get 216? Well, they did this. They multiplied length times width times height, and I should have put it here. It would give me 216, so that I can start formulating or writing down my equation. Okay. So I can multiply 8 times 9. 8 times 9 is 72. Right? And remember, the goal here is to get h all by itself. Now I'm going to get rid of the parentheses because there's no confusion with 72h. We know that 72 and h are different numbers. Okay? And so that's going to equal 216. And now the last step would be dividing the 72 away from the h, because right here they're multiplied together, and to separate them so I can get the number to group over here with the other number and leave the h by itself, I got to divide. So I would divide both sides of the equal sign of the equation by 72. So whatever number divided by itself is 1. 1h, I already talked about this, is going to be h. That's 1h. I don't need to put a 1 in front of it to show that it's 1h, right? All right, so I'm going to go ahead and get my calculator out and do this division. 216 divided by 72, right? And I think you guys know how to do that, so I'm not going to show you. I'll just be a little bit quicker about it here. By 72 is going to be equal to... I didn't do that right. Sorry. Okay, it's equal to 3. So the height of this rectangular prism is 3 centimeters. Okay? And so if you were to multiply 9 times 8 times 3, you'll get 216. And that fits the formula. I mean, that fits fits the same equal volume for the two different figures. Okay, so basically what we're saying is if you multiply 6 times 6 times 6, you get the same as if you were to multiply 9 by 8 times 3. Okay, so these are very typical problems, and like I was saying, sometimes later on we'll probably look at a problem that will be a cylinder or a different shape, maybe a pyramid and a rectangular prism, and they have the same volumes. So there you're looking at different formulas, but because each figure has its own formula. Here, they're both boxes and they have the same formula. They're both length times width times height, no matter what you do. But when it's a different shape, it has a different formula. But they can have equal volumes, and sometimes they'll throw this same kind of problem at you. What's the height of the pyramid? And you're like, but that's where we have to, you know, use our algebra skills. So anyway, that's basically what I'm going to talk. That's basically my little video here for volume of rectangular prisms, or as I like to call them, boxes. Remember that, use your hands and think about those 3 dimensions that we're talking about. It doesn't matter which way you multiply them, but you got to multiply all 3 of them to get the volume. And if you have the volume, you can use algebra to find one of the, maybe one of the dimensions of the figure. Okay, so keep practicing. Good luck.